Hi friends, welcome back. Today we're talking about graphing logarithms as exponential inverses. Okay, what does that mean? So here we're given this logarithm and you're told to graph it. If you're anything like I was when I was your age taking Algebra 2, I looked at that and I was like, I'll just plug and chug, do an XY chart and that'll help me and I'll figure it out. You could absolutely do that. However, I've since become like the laziest person you'll ever meet and I want to do things the easiest way possible. There's a much easier way to graph these, especially so that you get some nice, pretty, clean numbers that are not messy looking. Here's how you do this. Okay, the first thing you do is we are going to take a look at this first one and we see that we have log base 2 of x. The first thing you want to do is find your inverse. And you could do that by swapping your, change this to a y and then swap your x and y and solve for y. Basically, you're putting it in an exponential form. The easiest way to remember to do this is find your x and look at the base of the logarithm there. Our inverse is going to be this, 2 to the x power, 2 to the x power. And what we're going to do is create an XY chart. I don't like that pen because it's not as dark. I want you to be able to see. So I've got my XY chart here. I'm going to choose some numbers, -2, -1, 0, 1, and 2. I'm a creature of habit. Those are the numbers I choose every time. So looking at this graph right here, if I were to, let's start with 0. If I were to plug in 0 for x, I would have 2 to the 0 power, which is 1, right? If I were to put in a 1 here, 2 to the 1 power is 2. If I were to put in a 2, I'd have 2 to the 4th power, or 2 to the 2nd power, which is 4. Where it gets a little bit tricky, and we'll do a little side work here, is if we have 2 to the -1 power. Remember, that does not affect your base. That's not -2. All that is a negative attitude. And currently that attitude is upstairs. We need to kick it downstairs and change it to a positive attitude. So what we have now, instead of 2 to the -1, we have 1/2. Again, if we do the same, 2 to the -2. Okay, well, it's currently upstairs and it's got a bad attitude, so we're going to kick it downstairs. It changes the attitude to positive, and we have a 1 up here. So 1 over 2 squared, which is just 4. So 1 to the 4th. And you'll see, do you see how it goes 2, 4 here, and then 2, 4 here? You'll start to see that that pattern repeats itself. So, okay, we've got, so if I were to graph this exponent, done. This is it. I would just grab those points and I'd be done with it. But remember, this is the inverse of log base 2 of x, which means when we have an inverse, the domain of one function is the range of its inverse. The range of a function is the domain of its inverse, and domain is just x and range is y. So all I'm saying there is in order to change it into the inverse, which looks like this, we just have to swap our x and y's. So my y is now -2, -1, 0, 1, and 2. And my x's are these guys, 1/4, 1/2, 1, 2, and 4. So we go over 1/4 down -2. So over 1/4 down 2, that's like right about there. We go over 1/2 and down -1. We go over 1 and down 0. We go over 2 and up 1. And over 4. So that's 3, 4, and up 2. So you'll see that I have these nice, pretty numbers here. Had I chosen something like a 3 to insert for my x, I would have gotten some weird decimal, and it's hard to graph those. So this is a much better way of graphing because it's more accurate. You get some points, and you get some actual points that aren't decimals, and it's easier to graph those guys. So there you go. You just graphed it. Let's try another one. This one's a little tricky because it's 1/2. Up here, our base was a 2, which is a whole number greater than 1, so it was growing. When it's an exponential growth, it's a growth. This one, our base, again, you look for that x and you look for the base on your logarithm. So it's y equals 1/2 to the x power. So we've got x, y, -2, -1, 0, 1, and 2. And again, I like to choose 0 because you start there. Anything to the 0 power is 1. Now, 1/2 to the 1 power is just 1/2. 1/2 to the 2nd power, remember, 1/2 to the 2nd power is the same as saying 1/2 times 1/2, which gives you 1/4. So this is going to be 1/4. Now, what about 1/2? Let's do some side work here. 1/2 to the -1 power. When we did this when we did 2, we distributed it to the top and the bottom. So what this really is 1 to the -1 over 2 to the -1. Those both have negative attitudes, so I'm going to fix it. 2 to the 1 over 1 to the 1. All that does is simplify down to 2. We can do the same thing with a -2 here, and we would get 4. Again, do you see that pattern? 2, 4, 2, 4. So you'll start to see that pattern, and it's really helpful when we get into graphing some of these that can be a little more complicated. Also, the good news about this is if you learn to graph this way, all your other functions, when you get into pre-calculus, all your other functions are based off of this translation, which we'll get into in another video, so that you can identify how to move these around and start to see those relationships between all these other different types of functions. So this is a good thing to learn. Okay, so this is our exponential function. And remember, we want the logarithmic function. So we want the inverse, which is y equals log base 1/2 of x. And when we do the inverse, we've got to swap our domain and range, our x and our y. So our y is now -2, -1, 0, 1, and 2. And our x are these numbers that we found, 4, 2, 1, 1/2, 1/4. Okay, so taking a look at this guy then, we go over 4 and down 2. So over 2 and down 1, over 1 and up or down 0, I guess you could say, over 1/2, up 1, over 1/4, up 2. So you can see again, this one, because it's smaller, because 1/2 is smaller than 1, if it was exponential, it would be decay, which means its inverse is shaped like this, as opposed to this guy right here. Okay, we've got one more to graph because I want you to really practice those fractions. So if we have these guys, let's take a look at this one. Good. Okay, so looking at this, we first have to find our base graph. And our base exponential graph is, we find the x, we use our base for our exponent there, so we're going to say 5/2 to the x power. Okay, so let's figure out how this is going to work. When we put in 0, we get 1, right? Because anything to the 0 power is 1. If I put in 1, I get 5/2. Now 5/2, I think it's easier to convert it to 2.5 or 2.5 because when we're graphing it, it's a little easier to count that out. So 2, if we do to the 2 power, that would give us 5 squared over 4 or over 2 squared, which is 4. So we would get 25 over 4, and that's going to give us 6 and 1/4. 6 and 1/4. Okay, what about -1? Let's do some work here. We've got 5/2 to the -1, and remember that gets distributed to the top and to the bottom. Now swap those around, we get 2 over 5. 2 to the 1 over 5 to the 1, which is just 2 over 5. So 2 over 5. We're going to do the same thing with -2. So we've got 5/2, -2. Swap those around, we get 2 to the +2 over 5 to the +2. So we get 4 over 25. And again, if you see these patterns, see this is 5 over 2, this is 2 over 5. This is 25 over 4, and this is 4 over 25. So when we go to do these guys, if we do 4 divided by 25, that's going to give us 0.16. And then 2 divided by 5, that'll give us 0.4. Okay, so now that is, again, our base graph, but we want our logarithmic graph. So, or our exponential graph. That was our exponential graph. We want our logarithmic graph. So 5/2 x, just like this, and you'll see that I've already put my my x's in here. I put them in for my y here, and so my x now is 0.16, 4/10, 1, 2.5, 6 and a 4th, which is 0.25. If you want to keep it in decimals or fractions, doesn't matter. We go to graph this guy, we go over 0.16 down -2. So over 0.16 down, that's going to be like right there. Over -1 and down about 1/2, right? So over, so we go, oh, whoops, I did this wrong. I'm so sorry. We went over let's try that again. Over 1/2 and down -1. There we go. Okay. Over 1 down 0, over 2.5, which is right here, up 1, and over 6 1/4. So let's say 3, 6, so 6 1/4 and up 2. So like maybe right about there. Again, you're not going to get really like tight numbers on this, but it gives you a good idea. Again, I'm not going to be crossing that 0. I probably should have pointed that out on those other ones to you, because when we have logarithms, we cannot have a 0 in, or we cannot have a negative in here. So you'll see that that's that asymptote that doesn't allow us to cross. Hopefully this makes sense and you've learned something new. Otherwise, we'll see you next time.